Okay, hello, good morning, ladies and gentlemen. My name is Jerome Sadler, and I'm an AI partner working for RiverSafe. And I'd like to spend about 25 minutes today talking to you about our experience implementing AI-driven or LLM-driven applications in enterprises. I have very few slides today. Most of this is a demo using an example app, but we'll be touching on the following topics. So we'll be talking about things like visualizing your code base very quickly, looking at applying standards, the way in which we monitor the quality of the responses that we get from an LLM-driven application, and the way in which we then can react to that to ensure always that we're providing value for the customer as they are using these applications. It's a very important topic. So we have an example application called Neurologic that we use to touch on those topics that we talk about. Now, we have implemented this on various customer sites, and we work a lot with customers on these kinds of models, and there are a few different use cases, but broadly one can talk about knowledge management use cases where you are using LLMs, RAG-driven applications to bring together all sorts of data sources across the enterprise, for example, from Confluence, from SharePoint, from wikis, from all sorts of document data sources, in order to bring them together and make them accessible and distill them for users within the enterprise. The use case we have today is a different one to that. This time we have pointed Neurologic at source code in various GitHub repositories. So I can show you that we have ingested here 10 repos, mostly public repos from GitHub, but a few private ones as well. And those will form the basis of the interactions that we have here. Now, this scales to a lot of repos, but for the purposes of this demo, we have this just with these 10. So let me find my way back here. So the use case here, let's give an example scenario, is that we have a large number of repos, but we have, for example, an application where we have absolutely no idea what it does. We have the source code, but the developers who have been working on it and have either left the organization, or we need to understand that particular application. And this scales across multiple applications. So we can look not just at an individual application, but we can look across repos, across the organization. Now, in order to understand these repos, if I as an SRE come into an organization and say, I need to now understand the landscape, I need to understand all of the applications, I need to understand the standards that we have in place, I need to understand the automation I have in place, what do I need to do? I need to go and look at the repos myself. I need to use to schedule meetings with colleagues who have tacit knowledge locked in their heads about these particular applications. We have the knowledge made perhaps more explicit in documents, but documents are often either non-existent, out of date, or just plain inaccurate. So it can be quite an inefficient process to be able to understand that landscape. Let's say that one of the repos, applications that we have ingested here, we don't understand what it does. We just want very quickly to understand at a high level, what does this do? So Neurologic, as I say, is a RAG-driven application, so retrieval augmented generation, that it streams the response. One of the things about models, and we use various models to depending on the use case, is that there is a trade-off between the accuracy of the response to a degree and the speed with which a model will respond. Because we have this concept of context windows, which is basically how much information the model can take in and how much information it will be able to output, usually measured in tokens. What we do very typically is stream the response to give the impression the user give a much better kind of experience, even though, because otherwise you would be waiting 20, 30 seconds potentially, depending on the model and the use case, for that response. And this is RAG, so we can click in. I won't click in here because it's slightly awkward with this demo setup, but you can then click into the actual sources of the data, and you get a response that tells you, what is this? Now, text is fine, but visualizations tend to be rather more useful and enable you to really understand things at a glance much more easily. So again, we can use an application such as Neurologic to visualize aspects of a particular application. So let's say, one of the repos that we've ingested is the LibreChat, which is a social media application. So let's look at the authentication process in LibreChat, and ask to have a sequence diagram, so with the actors and the different messages between the actors, to understand how authentication works with this particular type of authentication type. It uses different social media authentication ways as well. So you have an example of the explanation of what's happening. We draw a mermaid diagram. This is a mermaid diagram that will appear shortly on refresh. I hope. There you go. And you can see what that process is. You can also export that mermaid diagram, do what you like with it. But the key point is it is visualizing a pattern used by this organization. And one can, of course, extend that in potential scope to look across the organization, across the repos, to understand the different patterns that are being used for this this particular scenario, which is user authentication, and then start to standardize. If we have a pattern which we want to implement, or to say is our standard way of implementing something within our organization, it could be an evaluation pipeline for an LLM or something like this, and then you are able to start to report divergences from that pattern. You make a decision in an organization if those are meaningful or not, and then when you are newly implementing something which touches on that pattern, you're able to then invoke this kind of knowledge. So it really democratizes the understanding of these patterns across an organization to say, how do we do user authentication within my organization? This is how we do it. There's an important topic here also I mentioned earlier, which is the use of metrics. Because when I started working in this area, I was working with my colleague Evren, creating convolutional neural network architectures, training models. We don't do that anymore. We've moved away from that because we have the big organizations like OpenAI and others who provide models, and it's moving very fast with different evolutions of models. And then we use RAG-based processes and different workflows to feed those RAG-based processes, and that's where the art is. That's a lot of the consultancy we do with customers in order to get the best responses possible. We all have had experiences with ChatGPT where we ask it something and really think that's not a terribly good answer. We do a lot of work with the metrics, monitoring the metrics of the responses that we get from these models for customers. For example, when you add data sources, or when you add data, if you make changes to repos, that data is changing. Now, in the olden days when I started this, it was quite simple because they tended to be classification problems. Is there a cat in this picture? Is there a dog in this picture? And you train your model, and then it's a yes or no. LLMs spew out free text. And on top of that, because it's a probabilistic model, it spews out different text for the same answer, but semantically equivalent. So the question then becomes, how does one gauge the accuracy of an answer and the usefulness of an answer in a situation where the words are not the same? So I will just, oh gosh, this is the, I've got it here in fact, good. I can't actually see, yeah, there we go. The industry is homing in on an approach which uses another LLM as an arbiter in that case, to be able to say, this answer is the equivalent of the answer that is correct, or we believe is correct, or how close it is, and there are metrics associated with it, and therefore we believe that there is value in that answer. We've tried all sorts of different approaches. We try to get people to put a thumbs up, thumbs down if the answer is good, or if the answer is not so good. Nobody does it. I don't even do it for things. So it's difficult to gauge. So in order to justify the value that you're delivering through these kinds of solutions, there are frameworks that are emerging within or that have emerged within the industry. We use the RAGAS framework, and you can see that for all of the user prompts that we have had today, we get faithfulness and relevancy. These are two metrics. There are many more, which tell us, let me get this right, faithfulness is the extent to which an answer can be inferred from the facts in the source. I'm thinking of my son's 11 plus yesterday when he was doing nonverbal reasoning. So the extent to which the answer can be reached by inference from the data in the source. So there's no hallucinations, or there's limited hallucinations, there's none at all, and it follows logically. And relevancy is the extent to which the answer is relevant to what was asked. Now, these are two example metrics, and we get these metrics, and then we're able to monitor those metrics as they change over time and start to understand actually why is it that we're starting to see these lower kinds of numbers. In general, we would look for metrics 85% and above, and I've got some examples here which are below. So we would then go and have a look at those queries. We'd have a look at the answer, or those prompts, have a look at the answer, and then be able to say, okay, we can see why that's starting to degrade. In the old AI world, we still call it data drift, and then we're then able to make adjustments to our workflow to ensure either to our workflow or to the data sources. In other words, is there a document that really reflects, or is there some code that really reflects what this is actually intending to answer? Make adjustments to the ingestion process, and then improve the quality of those answers. So we're always monitoring that, because otherwise it feels as though one is somewhat blind in assuming that the answers are relevant and useful. So if I go back to the dashboard, see very well here. Oh, I'm very happy to take questions. Yeah, please. This is a framework called RAGAS, which uses, as I say, another large language model as an arbiter, and then the scale is from 0 to 1. 0 being not a good answer, to 1 being a highly accurate for the different categories of metric. Yes, yeah.
So the question was, are you feeding you're using a second LLM to get these scores, and are you feeding them the second LLM with the same query, the same data? Because that's what RAG is all about, right?
Yes, that's right. That's right. There's a lot of details around that, so I'm very happy for us to have a chat with you afterwards, but broadly, yes.
Okay, thank you.
Yeah, cool, good. So yeah, metrics is really a very important element of this, so that you can really and if you look at the answer, let's say the response relevancy graph here, we have in deference to the demo gods, we don't ask Neurologic anything on Friday the 13th, apparently. But beyond that, you can see that the minimum relevancy number, the maximum relevancy number amongst the questions that we're asking, and then the average, and then you can start to work out if you're seeing a degradation over time, what kind of degradation are you seeing, and how do you continue to make this more and more useful for your users. Let me go back to Neurologic itself. When you're talking about standards across an organization, you might want to understand, let's say that you are implementing something like a 12-factor app, or that you are looking to break up a monolith and say, how do I define the boundaries of my microservice? There are very good use cases in which we can use this kind of application with the kind of prompt engineering and ingestion processes that I've been talking about. So let me look at the FN Data Science Development Project, which I know is fundamentally monolithic. You have to say that the answers in this kind of case are much more like talking to an expert colleague. If you have 3 expert colleagues, they will give you slightly different answers, probably, certainly if you're talking to an architect. If they're asking for things like a question like, what should the service boundaries be for this application, and why should that be? So nobody is suggesting that from where we are in the industry today, or at least I don't think people are suggesting that it is giving you the absolute answer that you need for this kind of slightly broader scale question. But what you can say is that a well-architected LLM-driven application will occasionally make mistakes, but give you tremendous value most of the time without making many mistakes. A badly architected LLM-driven application will make a lot of mistakes all the time and will lose user confidence in those answers. So I think of these solutions today, and as I say, the models are evolving constantly, as being like a highly expert colleague. Now, I was going to show you, there's a model that's come out very recently from OpenAI, the O1 model, which builds on the 4.0 model. But I can't show that today because we have a LibreChat implementation where we change between models to look at the differences. It doesn't actually support 4.01 yet. But 4.01 is optimized for scientific, mathematical, and allegedly PhD level science responses. And it uses different types of processes under the covers, something called chain of thought prompting. When I've tried it in other contexts, it's quite slow. Yeah? It starts to move away from a chat-like experience. So this is what I'm talking about in terms of that balance between latency of response and accuracy of response. So we've got various ways which we've developed over time to think what is an appropriate candidate for a chat-like response, and where do we use other engineering techniques on top of just pure AI techniques in order to be able to deliver value. So one of the things we do, we have a batch process here, which I will show, where we generate technical documentation as we ingest the repositories. And the technical documentation is in a customer's standard format. So if you wanted to create technical documentation, it always looks the same way. Importantly, it is rooted in the source code. It is not driven by READMEs. It is not driven by other extraneous sources. It is rooted in the source code. And you are then able to look at, this is a format that an organization gave us, but you can see that we have a component diagram, we have a flowchart for the high-level components, all sorts of elements of a technical design document, which, in this particular case, this organization wanted to, as part of their technical documentation. Now, also very importantly, this is created on ingestion of the repo. If I go back to the dashboard, you'll see that ingestion, the longest ingestion for this particular period was 53 minutes, which was a large repo, and the documentation is generated, takes about 2 minutes on top of that. I don't think the 53 minutes includes that. So we are in a situation where you create up-to-date, fully correct technical documentation when the repo is ingested. You don't need to re-ingest the repo when you make changes to the repo. We have a process that looks at those deltas and then recreates the documentation in about 2 minutes once those re-ingestions are done. So it's much faster and importantly costs less, because when you ingest a repo, you take the cost of the LLM processing that takes place through the ingestion process. It's not a particularly expensive thing to ingest a large repo like that. I think the most we saw was something like $150 on current prices with OpenAI. But with the Delta processing, it's effectively a one-off, because with the Delta processing, it's very little afterwards once you make changes to those repos. To update that documentation, and really importantly, it's always up to date. And it's very easy. You don't have to go and get someone to completely write the new documentation for you. Another thing I wanted to talk about, there are a lot of topics here, so it would be lovely to talk to other people afterwards, is good prompts versus bad prompts. Because we find that on the latest data I was looking at, 47% of users of one of our solutions use single word prompts. Helm, Kubernetes, something like that. And of course, if you go up to an expert and you ask them a question, they need context for that question. They need to understand what you're trying to, the perspective you're trying to have on that problem space, and then they will give you a better answer. Quite a lot of what we do in looking at what people are asking is then identifying the types of questions they ask, and also looking to educate and understand people so that they understand that actually you need to put some ceremony around what you're asking, and the prompts can be quite long in order to really get the best quality answer. One last thing I will show before my time ends. There is this idea of the illusion of a good answer. You can look at an answer and think, yeah, that looks right. But when you start digging into it, and this is where people lose faith in these kinds of products sometimes, actually, it's not that right. So I will use a very long prompt, if I can just get to it. So I've made up some very arbitrary reading standards here, which are intended to prove a point, so please don't take them too seriously, which is when there should be comments, variable names, how they start, and I'm asking the application to do that over 5 classes, or 5 files in this case actually, I will show you what comes out. So what will come out is something that looks reasonably plausible at first glance, I hope. But when you start digging into it, you will see some limitations. So what I'm expecting to see, and this is probabilistic, so I don't always know exactly, what I'm expecting to see is that, let's have a look. I know the numbers are not totally correct. And I know that let's have a look, how many? 1, 2, 3, 4, 5, yeah. Quite a lot of the time, it will not look at all of the files. Quite a lot of the time, it will give you a response for 3 of the files or 4 of the files, but not 5 of the files. In this case, it's actually let me down by giving me 5. But quite a lot of the time, it won't. So I'm giving you an example of where these context windows, these ideas of how much the model can see at any given time, and how much it's then able to respond with, varies. So this is why we make these judgments about what is a plausible prompt for a chat experience, and where those numbers are not quite right, and where we would have something that takes place during ingestion and be able to provide that level of information to users or to whoever needs to be able to see it at that point. Now, as I say, these models, context windows have got so much bigger already over the last year or two, but the larger the context windows, the slower the response will be. So this is the kind of balancing that we tend to do. Right, I think my time is up. Any questions? There are lots of things we could talk about. Oh, is it on? You'll have to talk loudly. I can hear you.
I was wondering, after you explained that you have this accuracy and whether you will still show an output that shows badly in these metrics, or you will just say...
In which we simply respond, we don't have a good answer now, but are these suggested prompts, we suggest prompts as well, useful to you in order to narrow the scope? Basically something along those lines, a bit more elegantly phrased. Yes. Yes. That's right. That's right. And actually there was something that I didn't show, but another important, you've just reminded me, for showing metrics, which is really important to monitor what are the prompts for toxicity. Because you as an organization can get banned from using these models if people are submitting toxic inputs, toxic prompts. So I actually had a tweet by Donald Trump, which Neurologic picks up as a toxic prompt, and I was going to show you that, but I haven't got time. So anyway, something all in capitals saying everything was rigged. We got another. So yeah. Yes. Yes, so there are different ways of doing this, and we talk with some organizations who don't want their data going out to cloud-based models for all sorts of reasons. Now, there are multiple ways around this. First thing to say is that you do have contractual, and we've been through this process with contractual arrangements with cloud providers to ensure that your data is not going to be used to train other data. But you can also run open source models locally. So you could use this application with open source models running locally. We use Kubernetes as well, like Sebastian was saying, to run these processes. Your data never leaves the boundary of your organization. Now, it's important to say that the open source models are not quite as good as the ones that are on the cloud. So there's different engineering principles that one would need to take in order to make sure that you get as good a set of answers as you do when you get on the cloud. But fundamentally, you can run these models locally. Okay. Another question over there. Never mind. But please, I'd be very happy to talk to anyone afterwards, or my RiverSafe colleagues, to